All right, we're going to spend a few days just with more problem solving. So all the different kinds of situations, as we've talked about over and over again, we've looked at the four different ways that you can represent a linear relation. And so all the problems are going to start with one of those four ways, and you're going to be required to answer some questions. In some cases, it may tell you sort of step by step, a little bit at least, what you're supposed to do, but in some cases it might not. It might be kind of wide open. A lot of what we're going to do will be EQAO kind of stuff. We're going to see some multiple choice, some open response, and some other just maybe more straightforward questions. And again, it always comes down to the same idea where we're trying to figure out the specifics of the linear relation that we're looking at, and that always comes down to those two important properties of the linear relation. Where does it start, and what is the change, or what's the rate? And we have determined, we have practiced and practiced from the four different ways how you can find those two things, right? But there are going to be some new sort of types of questions. In fact, example number one, I think today is there's not really anything new about it. So it's just more good practice. But example number two will have something a little bit different. And that's the kind of thing that we're going to do over the next few days. Okay, so let's take a look. Example number one. A Christmas gift basket shop charges its customers a fixed amount for the basket plus a fee for each item in the basket. The total cost, C, based on the number of items in the basket, N, is given by the equation here. Now, before we move on, I want to make sure that everybody understands what this is talking about. You have probably seen these gift baskets. They're often in some kind of like a nice looking basket with a big handle. They're usually wrapped in plastic, and they have a variety of things inside. They have things like chocolates and coffees, or mugs, or sometimes fruit, teddy bears, like all different kinds of things, right? So this is like one of those gift basket places where you can customize your basket. So you can decide what to put in it. And these are popular around the holidays, whether it's Christmas or any other holiday. Okay, and something you might not know about these, I'm gonna hope that everybody or almost everybody has seen these before, has heard of these. You kind of know what we're talking about. Um, but what you might not know about them is they can actually be really expensive. So you see these going up to $50, $60, $80, $100 or more. And at least in my opinion, they don't even look like they have that much stuff in them. I mean, it's a big basket, and it's obviously got some stuff in it, but nothing usually looks all that expensive, and yet they can often run upwards of $100 more. So keep that in mind. Um, but anyway, now that we've sort of established that that's what we're talking about, let's think about this. When I look at this equation, and as we've talked about, two important things, we have the start, which is the number all by itself, and we have the rate or the change, which is the 3, not 3n, but 3, okay, the number that's beside and being multiplied by the variable. And when I go back up and I read the question again, there's a fixed amount for the basket plus a fee for each item. So this makes sense when you think about it. You go into the store and you pay just for the basket up front, because the basket itself is going to cost some money. And then at this store, this shop, every item costs the same. In real life, again, they would probably be different, right? You'd have expensive ones and cheaper ones, but at this shop, they're all the same. And so you buy the basket, and then you put as many items in it as you can fit or as you want to pay for, and they all cost the same amount, right? And the total cost for your gift basket will be when you add those two together, depending on how many items you choose, and then you'll add those together. So if I want, before we even get to the first question, what is that fixed amount? Well, that's the $12, right? That's the starting fee or the initial fee. And what is the cost per item? $3, right? It says for each and that's the same as per item. Those are the keywords that we're looking for to find the rate or the change, okay? And so this is $3 per item. So again, this is something we've talked about, and I think this is a really good way of thinking about it. Let's say you buy the basket and you only buy one item, which would probably look strange because you'd have a more or less empty basket with one thing in it. But anyway, that would be the $12 for the fixed fee and the $3 for that one item. So you'd be paying $15, right? So for one item, you'd be paying $15. What about for 5 items? Well, I'd still pay the $12, but now I'd be paying $3 per item for 5 items. That's $15 total, right? Because 5 items, $3 each is 15, and 12 plus 15 would be 27. So the total is made up of those two parts, the fixed part and the total cost per item part, right? And those two add up to the total cost of the basket. And so we could make a table of values by continuing to go through that. We're not asked to, so I'm not going to do that. But again, I haven't even looked at what the question is actually asking me to do. I've just started thinking about this situation. And this is a good strategy because, as I said, a lot of these questions are going to ask you to do different things. And sometimes that's very confusing where you're like, ooh, I've never seen this before. But I haven't even looked at what the question is actually asking me yet. And I've already kind of been coming up with some understanding of this situation and breaking it down into its parts so that I know what's going on. And that's going to put me in a position where I'm more likely to be able to sort of successfully answer whatever questions come up. Okay, so we've talked about that. Graph the relationship between number of items and total cost on the grid below. Well, I can say, I can start this in a couple of ways. We've got the $12 fixed, and I just know that as the start. So I can find 12 on the vertical axis there because this axis, this line here is always where the start goes, okay? And I can just find 12 because I know it's the start. But I can also think that that's how much you would pay for 0 items. It doesn't make any sense to actually do that in the real world. We've talked about this too. You would never buy the basket with 0 items. I guess if you just wanted a basket, maybe you would. I don't even know if they would sell it. But anyway, that's generally not the idea, but that's how the pricing structure works. Okay, so $12 for 0 items, so that's where we're starting. And every time I go up one item, I'm going to go up by $3. But I don't know that I want to plot every single line or every single point, sorry. So remember we did 5 items, and 5 items at $3 each was $15, plus the 12 is, whoops, 27. So what I could do instead is I could go to $5 and I could go up to 27, and I can see that this is counting by threes. So 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. So there's my 27 for 5. I could go to 10 as my next one, and $3 each for 10 items is $30, plus the $12 fixed is $42. So 10 and follow it up to 42, and we can see that 42 is written there. And now I've got 2 points after the start, and 3 points is good to draw a line. 2 points isn't really good enough, because if I just did 2 points, watch this. I might do this because it kind of hits both those points, but look at how far it misses the third point. And by the time I get up here, I'm way off track. So that wasn't a good line that I drew. And the reason was because I only went through 2 points. So what you want to do ideally is go through all 3 points and go through the middle of it as best as you can. Okay. And do your line all the way to the edge of the grid like that. Okay, that's ideally what we want to do. And if you go through all 3 points, there's pretty good chance that your line is going to be very, very accurate. Okay, if you only go through 2, it might not be that great. So I could have used these points down here, but it makes it a little bit trickier. So if I spread the points out a little bit more, again, that's a way to make my line look nice. Question A was just graph the relationship on the grid below. So we are done with that. Find the total cost for a customer who buys a basket with 14 items. Use the equation and then check your answer on the graph. So this is something that we've done, but I have to use the equation. So remember, C is the total cost, and N is the number of items. Okay, and we've talked about what the 3 and the 12 are. And so for 14 items, that's saying N is 14. So what do? I want to find the total cost by putting 14 in for N and then solving this equation. Okay, so I'm going to use my calculator for this, and I'm going to go 3 times 14 to find that part. You could do this all at once. I've said this before. I like to do it in 2 parts because I like to see that the 42 and the 12, where each of those come from. I like to think about how the 42 is the cost for the items, right? And the 12 was the fixed cost, in this case, for the basket. And then when I add them together, so 42 plus 12, I get my 54, which is my total. Okay, therefore, the total for 14 items is $54. Okay, and that's how you use the equation. Okay, the biggest trick about the equation is when it gives you the number that you want to put in, or that you have to put in. Is it going in for that variable, or is it going in for that variable? And that's something we're going to talk more about later, but it could go in for either of them, right? But in this case, it's the N, as I said. Now, the last thing it says is check your answer on the graph. So for 14 items, hopefully my graph is good enough. I am going to follow. Okay, so I'm going to follow from 14. And this is, if you have to show your work on the graph, this is how we do it. And I call these sight lines. Okay, and so they're little dash marks that I make with the ruler. Whoops, I still need that. I make them with the ruler and I show them on the graph to show that I'm following from 14 up to where it hits the graph. And then from there, I'm following it over. And this one's easy because it's on these grid lines, but sometimes it doesn't. And we'll see that in a little while. In about a week, we're going to look at something where that will happen. And it's not going to be a nice, perfect number like this, right? So there's our answer, 54. But these sight lines are a good way of showing how you checked your work on the graph. Okay, and it's a good way of making sure that you're perfect, that you don't kind of miss and go off somewhere. And take a look at that. $54 is what we found. The graph agrees, and so we're good. Okay, so again, that was kind of review. We've seen a lot of that already. Bit of a warm-up, maybe you would say. Question number 2, as I said, is going to be a bit different. 2 limousine companies have different methods for charging their customers. Now, let's think about each of these on their own. And in fact, here's what I'm going to do. I'm going to erase some of this. And let's just look at company A all by itself. No initial fee. So that's talking about the start. And this is what the company charges, $16 per hour. So start is 0 because there's none, and the rate is 16 because it says 16 per hour. That's company A. So you can see that it is a linear relation on its own, ignoring anything else in the question. This is a linear relation, and this is the representation with words. But again, I could take this and forget about what the rest of the question is going to ask. If I wanted to, I could turn this into an equation, I could turn this into a graph, and I could turn this into a table of values. Those are the other 3 that we've looked at, right? Okay, so that was just for company A. What about company B? So let me get rid of all of this and let's just focus on B. Company B has a 24 initial fee. There's your start, because that's the amount up front. And $8 per hour. There's your rate. So again, for this one, I can break it up into those two important properties, and I can see that this is the description of the linear relation in words, and I can turn that into a rule or an equation or whatever I want. So each of these has their own equation, and separately they are linear relations. Okay, and I think we did talk about this at one point briefly. This one starts cheaper up front, but it's more each hour. This one is more expensive up front, but cheaper per hour. So there's a relationship here, and depending on how long you're going to use this, you're going to rent this thing, you might pick one of these companies over the other, and that is how the real world works. Often you have competing companies, and you have to decide which one is going to be best for you. For example, what if it's a cell phone plan and you're looking at the difference between Rogers and Bell? Well, maybe you use a ton of data, but not very much other stuff. And so that means Rogers is better. Or maybe you don't use a lot of data, but you use lots of other stuff. And so Bell is better, right? So different people are going to go with a different company or whatever, or a different plan that has a different cost structure because of how they're going to use it. And this is exactly like that. Write equations for company A and company B. So we've already kind of broken it down, each of these, into their parts. So A has a initial fee or a fixed fee or the start. I'm going to do this over on the side kind of thing. For A, the start is 0 and the rate is the cost per, so that's 16. And that makes my equation. It's a total cost, right? How much they charge. So I'm going to use a C for that. So C equals 16 times. So here we could use H, we could use N for number of hours, we could use T for time. I think we're going to find in the graph below that it uses N, so I'm going to use that as well. And then I've got the plus 0, which we don't need. So this is C equals 16N. For B, I'll have a start of 24 and a rate of 8. So this is C equals 8N. This is the rate. 8 is the rate, so it's with the N, right? Plus the start, which is, whoops, not 12. Don't know where I got that from. 24 is the start. So there's the equations for company A and company B. And it's nice to compare them, how this one starts at 0 because it has no initial fee, whereas this one starts at 24 because it has that fixed initial upfront cost at $24, and what each of their rate is. Now, it doesn't ask me to do this, but I'm thinking about it anyway. So that means this is direct variation, and this is partial variation. And that's something that's good to think about because it comes up here and there, and it's going to be useful to think about when we graph, which I think is what's coming up next. So I think that's it for A. Let's take a look at B. Like I said, I think we're graphing. Graph the relationship between the number of hours rented and the total cost for company A and company B. So we're doing both. Okay, I'll zoom out a little bit here. We'll do A first. A is direct. That means it starts at 0. Now, I already know that it starts at 0 because of the equation and everything we've already talked about. But again, that's what's important about direct, is that it goes through 0 there. So if I'm thinking about variation and that's direct, then I know immediately that my first point is down there. Okay, now we have to think about the rate. In the last question, I went up to 5 and then 10 to figure out some other points. Let's see what it looks like if we don't do that and we just count by one. So it's $16 per hour. Okay, so let's get that in and then zoom in a little bit here. So I'm starting at 0 hours. If I go over 1 hour, I go up $16. Not up to 16, up by 16. which happens to be 216 in this case because I started at 0, and going from 0 up to 16 is going up by 16. But that's what's important is I'm going up by 16, not necessarily going up to 16. Whoops, that'll be even more important or more obvious when we do the next one and compare the two. Okay, so from 1 hour to 2 hours, I'm going up another $16, up another $16, up another $16 every time I go over an hour. And it's pretty easy once you figure out that pattern. In this case, every time I go over 1, I'm going up 2 squares. So as long as I know that that's the correct pattern, I can plot in a bunch of points because, as I said previously, you'll get a better line if you have more points. Now, the thing that if you have some extra time, you're doing a test or EQAO, what might be a good idea is take one of these points, plug it into your equation, and make sure that you get the right answer. And the reason why you do this is because if you are just using the pattern, if you get the first dot wrong, every other dot afterwards will probably be wrong. So this is when we were doing this using the equation and then checking in the graph. This is also a good check that I've graphed properly and a good check that I've done the equations properly. So even though it doesn't ask me to do that, that is something that you could consider. All right, let's graph this. How's that look? Pretty good. Okay. And whenever we have more than one line on a graph or a relation on a graph, we absolutely have to label it. So this is company A. Just gonna, whoops, gonna, oh, geez, label it with an A. Okay. I'm gonna do the other one in a different color. So B starts at 24. So this is counting by 8s, 8, 16, 24 is right there. And it's going up by 8. Whoops. Okay, starts at 24 and is going up by 8. The change is 8. So I start at 24, and if I go over 1, I go up 8. So 16 was 2 squares. That means 1 square is half of that, which is 8. So up 8, up 8, up 8, 8, 8, 8, 8. Now I did even more points that time. See how close to perfect I can get this. That's pretty good right there. Okay, so there's B. And remember what we talked about. A starts cheaper, but it's more each hour. So eventually it's going to be more expensive. And look at how it's more money. If I draw a line down, this is for 7 hours. A is going to be 112, where B is only going to be 80, right? Um, so A is going to be more expensive if you go a long distance. B will be more expensive in the beginning because for $0 it's 24, and whereas whereas A starts at $0 or for 1 hour is only 16, whereas for 1 hour B is $32, right? So more expensive for a shorter time. And this is the most important bit of understanding when we're doing problems that involve more than one linear relation at a time. The lines are probably going to cross, and what we care about is when they cross and what it means before that point and after that point. And let's see, but that I was supposed to graph, so I graphed them both and I labeled them both, so I am done part B. Let's see what part C says. At how many hours do the two companies charge the same total cost? So where are they equal? Right here, which is at 3. That's where the two lines cross. That's where they cost the same amount for the same number of hours. So let me answer this question. The two companies cost the same for 3 hours. And that amount that they cost is they both cost 48. If I put 3 hours into each of these equations, I'd get 48 for both of them. Okay, that's what that means. Now, there's another thing that sometimes it just wants to know when they cost the same, but there are other questions where it says, when is it better to choose company A, or when is it better to choose company B, or something along those lines. So when is it better to choose company A? Well, you want it to be better because you want it to be cheaper, and company A is cheaper when the line is lower, and we know company A is better for fewer hours, for a shorter number of hours, shorter time, because it has a zero upfront cost, but it costs a lot each hour, right? So it ends up costing more later. So company A is cheaper. So the question didn't ask me to do this, but I'm just cheaper. I'm just doing it because I know other questions are going to ask this sort of thing. For under 3 hours. Don't say 3 hours or less, because that's not true. Technically speaking, they're the same at 3 hours. So it's for fewer than 3 hours or for under 3 hours. And B is cheaper for more than 3 hours. Now that's kind of like 4 hours or more. If you said 4 hours or more, that's kind of true, except, you could have 3.5 hours. So that would kind of not, even then wouldn't be quite perfect. So in this case, it's much better to say for more than 3 hours and for fewer than 3 hours or under 3 hours. Okay. So that's another kind of question that you might come across, and we'll see it together later, but you might see it in the practice where it sort of says, when would it be a better idea to use B? And you don't just say when it's cheaper. You say, no, like you have to say, when is it cheaper? And so in that case, well, it's cheaper for more than 3 hours, right? So for example, for 5 hours or 6 or 7, but again, you can't just say for 5 hours, you have to say the exact point kind of where they cross. Okay, so, and you have to say for more than 3 hours. So it's kind of picky. We'll keep talking about that though. We'll see more examples of that. So that was what was new today. That is the end of that question. I hope that makes sense. When you're comparing two linear relations in the same question and on the same graph, we can see that they cross because they have different rates and they have different starts, and we have to keep all that separate, but it still always came down to that. We came up with their equations, we graphed them, and then this was the new part where we really talked about comparing the two companies and when they're the same, or when it's better for one or when it's better for the other. And that is the sort of new and important learning behind today, comparing two different companies. So keep that in mind and look for those questions that are asking you to compare different cost structures or different linear relations. Okay, what I forgot to say was, I started off, when we did the first one, the company A, okay, the blue line, and I made a big deal about how going up by 16 doesn't necessarily mean going up to 16, right? It did in this case because I started at 0. Well, what I wanted to do is I wanted to compare these and say, hey, look, the company B, the orange line, is going up by 8. But when it goes up to 1, it doesn't go up to 8. It's already above 8. It's going up from 24 to 32 because that's an increase of 8. Okay, so this is going up by 16 every hour, 16 each hour. And because it started at 0, the first hour is at 16. But this is a good example of how that's what direct variation is like. And partial variation is not like that. Okay, partial variation going up by 8, but it never actually hits $8 because it starts above that in this case. Okay, so that was the other thing that I just wanted to point out, that That if that clicks for you and you get it, that's something that's a mistake that some people make. And once that clicks, you'll probably avoid that mistake. That when it says $16 per hour doesn't necessarily mean you're going to be at 16, right? Because that's the difference between direct variation and partial variation.